もしやコスモでは。
Cosmo needs me free.
Cosmo AP Luxury Sports.
It's part 41 of my 76 Mazda Cosmo restoration, and this time we're not going to do any complicated suspension engineering or fabrication. We're going to concentrate on one thing: tail lights. Specifically, we're going to convert these tail lights from crappy old incandescent bulbs to modern LEDs. Now these come apart a lot easier than modern taillights, which are often glued. Of course, modern taillights aren't full of bugs. "40 years of gunk." Now, from the local electronics store, I picked up a selection of LEDs just so I can determine which ones are going to look best behind the lens. And I'll just pop them on my breadboard and light them up. So every LED needs a series resistor to limit the current and the voltage. Setting all these up is a little bit tedious, and it's taking me back to my years as an electronics hobbyist. Okay, we're all wired up, so let there be light! Well, that's kind of anticlimactic, but LEDs. I don't think this translates well on camera, but to my eye, the two best are the two red LEDs. The white ones, they just look very orange. Now this is a 2000 millicandela red, and this is a 20,000 millicandela red. That's what I'm going to go with. One and 23. 1 and 46. Now these paper templates I drew up in CAD are just to let me visualize what this is going to look like. I've decided to outline the signal and brake areas with large 10mm LEDs and then fill in the field with 5mm LEDs. The reverse lights will just get 2 vertical rows of 10mm LEDs. Now by my math, that's 178 LEDs per tail light. So, I'm off to the electronics store to buy some LEDs. Well, okay, what I'm doing right now, since I'm waiting for my LEDs to arrive, is I am designing the circuit to drive them. I am doing two separate patterns, as I mentioned. The tail lights are going to be outlined in large LEDs, and then the field is going to be filled in by the small LEDs. I want the outer ring to be the running light and the inner field to fill in when I hit the brake light. My circuit is based on an ATTINY85 tiny 8-pin Arduino microcontroller. So I don't think that I can adequately cover the intricacies of electronic circuit design in this video, but I'm going to summarize it for the people who know a little bit about this. The brake light signal will be fed to the Arduino with a opto-isolator to isolate the processor from the 12-volt signal. The two analog outputs of the Arduino will drive a set of logic level MOSFETs. One MOSFET powering the outer ring of LEDs, the other MOSFET powering the inner field. Obviously the LEDs will be in a parallel series configuration with the appropriate series resistors. And of course the circuit will also consist of a small power supply section made up of a linear regulator to bring the 12 volts down from the car down to 5 volts for the microcontroller. And that finishes the prototype circuit. There's an Arduino AT85 Tiny, which PWMs two MOSFETs to control the two banks of LEDs. The Arduino is triggered by two opto-isolators that take the signal from the car's existing light circuit, and 5 volts to the Arduino is by a 7.8 low power voltage regulator. So next step is to draw that out in a little bit better version and then get the parts and prototype it. And that is the completed prototype circuit. Now, you've probably noticed the change of scenery. I am in the middle of transitioning to my new shop. So that said, because this is an Arduino, the magic in this thing is not really the circuit, the magic is the code that runs it. I've spent kind of some time when I didn't have the space ready writing that code because, well, I don't think it would be very interesting for me to show you hours and hours of me in front of a computer screen typing out C, especially since I don't know C. So what I will do is I will put a link to the source code in the description and put it up on the screen right about here. It's right here. Click it. It's going to go away. Okay, gone. Well, for those who didn't spend their youth on electronics, I'll just relate this to the schematic a bit. These two black things are the two opto-isolators. They isolate the signal from the car so that any surges and spikes can't damage the rest of the circuit. This is the ATTINY85 Arduino microcontroller that will take the inputs from the opto-isolators and will output it to these MOSFETs, which are basically switches that take a low current and can switch a high current. These LEDs, the big one and the small one, represent the big one, the outline border LEDs, and the small one will represent the field of LEDs throughout the light. And this right here is a 78L05 voltage regulator and a few capacitors, which form the 5-volt power supply to run the chip. Now, I've already programmed the Arduino with the code, so the only thing left is to fire it up. When I give it power, each LED should blink twice to say that the chip booted up and everything's good to go. Then you should see them fade in and out in an opening celebration. Okay, let's hope there's no smoke. Success! Now the way this works is as follows. Oh, I've turned down the brightness of the LEDs so I don't blind myself or the camera. This represents the activation for the running lights, which when turned on, light the border. This is the brake light. So when the brake light is activated, the field of LEDs in the middle of the light turns on and the border gets a little brighter. You may or may not be able to see that. Now, if the running light is not activated, but the brake light is, both LEDs turn on with the border being a little bit brighter than the inner LEDs. The opening celebration is cool, but if for some reason I switch a light on as it's happening, it is aborted and the regular function assumed, activated. Or if I hit the brake while it's doing its fanciness, aborted and the brake light is on. Well, the prototype seems to work as expected. So now the next step is to design and etch some printed circuit boards to make this thing permanent. The program I'm using to design the board is called the Copper Connection by a website called Robot Room. I kind of just discovered it, and it's pretty slick. It's a really easy to use CAD package for building circuit boards. It comes with most of the common parts, and actually is really damn easy to use. That's the key. I've tried Eagle and some of the others, and the learning curve is just brutal. And I don't expect any smart-ass comments about my monitor now. Now this program does copy and paste really well. I can make one circuit section and then just keep pasting it onto the board. I'm starting with the board for the reverse lights, since all it is a bunch of LEDs and series resistors. Very easy to make. Okay, now just a bit of fine tuning to line these up. Just print it out. One board. Now that seems to still fit. The LEDs look like they're in the right position. Time to make this into a board. Well, when I was a kid, my hobby was electronics. And when we wanted to make printed circuit boards, we would start with some blank copper-clad board and then draw on it with a resist ink pen or use those rub-on stickers and then etch it. All of that sucked epically. This time, I'm going to give these laser printer toner transfer sheets a try. It's the first time I've ever used them. Now this stuff is coated specially to allow a laser printer to print onto it and then allow the resulting toner to be ironed on to a printed circuit board. And you're really only supposed to touch them by the edges and not with your bare hands. Now, one thing I did was go into the service menu of the printer and crank the toner density up as far as it'll go. And then in the print driver, I've also cranked the toner density up to maximum. So I guess the only thing to do is print. Well, it went through the printer. I printed 4 on one page because I figured that would give me the largest chance of success. And these pages are about $3 a piece. The board needs to be insanely clean as possible, which means several rounds with the Scotch-Brite and some acetone. And naturally, no touching it with my hands. Clean. Now I would like to stress that this is the first time I have ever done this. I think a little bit of tape is probably not the worst idea in the world. And then, with an iron, as hot as you can get it, which I guess is cotton, start ironing. And obviously the iron needs to be dry, steam turned off. Now that's been about 2 or 3 minutes, and I guess now it's supposed to be put directly into cold water. This is going to be hot. Ow, ow, ow. Woohoo! Do I stir it? Ooh, it's starting to float off. Like magic is happening. Holy crap! I think it worked. I think I'm doing that again. I have to give this another try. As soon as I turned the camera off, all the toner started flaking off of the iron-on. So I tried 3 more times with the iron trying to get the hang of it, and I got pretty good at it. But you know what? I stole the laminator from the office. So let's see how badly I can break it. I should point out that this system is supposed to be used with a laminator. An iron is just a should work type theory. Oh, that is going to be hot. And then back through the other way. Let that cool off. Ooh. Okay, underwater it looks good. If you're going to do this, do not waste your time with an iron. That transfer is perfect. Now the copper not covered by the pattern has to be removed, which is done by etching it with ferric chloride. There are actually, stupid childproof, seriously? What child is going to accidentally? There are actually a bunch of chemicals that can be used, but ferric chloride is kind of my favorite. I've used it for a long time. Now it's not particularly dangerous to skin, but it will stain like you wouldn't believe. So I usually wear gloves. And then we agitate. And this will take anywhere from 5 to 15 minutes or so. I am going to call that done. And there goes my water. And I don't think the gloves worked. Well, the gloves did not work. My hands are stained for the next 3 days. For a first attempt, I think this worked really well. A little bit of acetone to remove the toner and reveal the copper traces. I'm pretty impressed. This is not too bad for a first try. And the one thing I'm going to do on future boards is just a little bit thicker traces.
Done.
And this is a 1/32 or 0.079 millimeter drill bit that I am shocked my drill press can actually hold. And I now have 28 tiny holes to drill times 2 boards. One. Done. Actually, it only took about 10 minutes or so. Now with the holes drilled, there is one final step, so that means another cleaning to get all the tarnish off that has accumulated. And because these boards are going into a hostile environment, i.e. a tail light, oh, I hate these things. That final step is to tin plate them with liquid tin. The boards just get immersed for 3 to 5 minutes. Oh, look at that, it's already happening. Okay, it's been about 5 minutes. And into the water. This stuff smells really weird. And after all of that work, it's finally time to begin assembling these boards. Now these are white LEDs with a forward voltage of just over 4 volts. So each one gets a series resistor of 82 ohms, assuming a supply voltage around 14 volts, and the 2 LEDs arranged in series. And now, of course, the LEDs themselves. And I'll need a set of power ground wires. That is one completed reverse light LED module. Well, naturally, we gotta fire it up. Yep, I'd say that's bright enough. No one's gonna mistake when I'm driving in reverse. Now just a little flux remover to remove the flux before it corrodes the solder joints. To protect the back of the boards, I'm going to use an acrylic conformal coating, which applies a fairly thick layer to seal it up from the environment. And of course, the other side of the board. Okay. I made the board with these 4 mounting holes and drilled matching ones, but the problem is, back of the light's at all kind of crazy angles. So I really don't want to just glue these things in, because I want to at least be able to perform a little bit of adjustment so it looks good under the lens. I've been trying to bend up a bolt to line it up, which I think is the right approach. So that's about the angle it has to bend to. Put a socket on it. Should just be able to. Well, that actually looks kind of promising. Just gotta make another. Off camera, 1 became 2. The idea is the board will just slip into place and hook over these. Okay, and that gives some adjustability because I'll just put a nut on the bottom of the board. That way I can raise and lower it until it's almost right at the lens. That way you can see each individual LED through the lens. Basically the same idea at the bottom, just get some shorter screws. Well, my hunch was close on the bottom one, but looks like I can't make it line up. Time to elongate some holes. Well, I'm not a big fan of grinding out holes in circuit boards, but consider that everything I'm building is essentially a prototype, and in prototyping, as in dating, sometimes you just have to punch out a hole in order to make things fit. This, however, seems to have worked quite well. Oh, hot! Okay, just slip it in. And the board insertion. Well, it's snug. This side of the board basically sits right on the retaining bolts, which is convenient. About 1 centimeter. I'm just trying to line these LEDs up. Now the whole idea is that I can then thread some nuts onto each one of these studs and be able to reasonably precisely adjust the position of the board. That gives me lots of fiddling room to get it close to the lens. So for now, I am just kind of screwing everything together lightly. It's all going to have to come apart a million times. Okay, one mounted board of LEDs. Just pop the lens cover on. Yep, position of them looks good. Now let's give it a test, because why not? That's a reverse light. So I was concerned that it wasn't necessarily bright enough. But this is what 20,000 millicandela LEDs can do. Yeah, I think that'll work. Jesus. Before I started the passenger side light, I had a change of heart and picked up some M3 threaded rod because the M4 bolts I was using were awful huge. I do seem to often have that problem in life, too huge a rod. Anyway, aside from that, the passenger side light goes together exactly the same way as the driver's side. I've also added these small nylon washers to provide a little bit of padding between the nuts and the case of the lights. God, it is very difficult to get my fingers around these tiny nuts. And that is not what she said. At least I've never heard it. And that's a completed passenger side reverse light. And obviously we need the money shot. So I think we're going to leave it right there, because I have a bunch more repetitive work to do creating boards for the rest of these light segments across 2 lights. We'll pick it up next time because the remaining light segments are going to be much more awesomer.